Okay, I'll just get started. So I'm Ming-Wei, and today I'm representing the Open Enclave SDK community to introduce you the SDK. So at this point, I assume all of you guys are pretty familiar with the concept of the confidential computing, right? Just a quick recap. The goal of confidential computing is ensuring the data is always encrypted throughout its life cycle. This including data at rest with disk encryption, for example, and data in transit using the TLS connections. And more importantly, the data in use. This is enabled with the enclave. And the enclave, as we all discussed throughout the day, is powered by the key point is the hardware-based trusted execution environment, TEE. Given this protection, attackers in this strong model, right? Attacker, for example, a hacker that hack into your system or a system admin or even the cloud provider cannot compromise the confidentiality and integrity of the data. And okay, let's see how we can actually develop an enclave program. And to start, the first thing is that a developer need to load their data into enclave to enable to create an enclave program. This means that there must be some point that the developer needs to copy the code and data from untrusted memory into a trusted enclave. And after that, the hardware will seal everything loaded inside the enclave, and that can be later used by the remote attestation. And creating the enclave in different TEE require really specific ways, depending on what TEE you are using, and it will be really difficult if a developer want to tackle this at its own. After creating enclave, the runtime support is also essential to support a program written in high-level language, for example, in C. And enclave has rather constrict environment. For example, all the host memory are considered as untrusted. So that means that an enclave program cannot use any library installed on the host. Also, few functionalities may not available inside an enclave. For example, system codes are not generally available, for example, in the SGX enclave. So this means that even we want to run a normal program inside enclave, it may not just work out of box. So it may require some tweaks to make them work. And lastly, the runtime support should make sure that the support won't break this TEE security model. For example, an enclave program cannot just use a row pointer that points to the host memory. And if that will directly leak the data to the outside world. So the last part is the attestation, which also a really important key part in the enclave program that allows a remote party to verify the identity of the enclave. This basically means the operation of the generation of the code that used by the attestation, and also there must be some way to verify the code. And given a different TEE, the format for the code may be different. And also to generate and verify a code, you will involving specific crypto operations or also interacting with the TEE hardware components. So those are, again, really tedious or difficult for a developer that don't have this kind of knowledge to implement all of them from scratch. And the goal of the Open Enclave SDK, or in short, OE, is to solve these problems and making it easy for a developer to write an enclave program. OE have a multi-TEE support. Currently, it supports Intel SGX Intel SGX as a main target, also has a private preview, a preview of support for ARM trust zone. For the runtime support, OE currently support both Linux running a SAN enclave program. So sorry, the run enclave binary in both Linux and Windows. And to support a normal C and C++ program, OE ported a C POSIX library based on Muscle, so that you provide mostly the C program written in C and C++ can be directly run on top of with OE. And based on the libc layer, OE support more third-party libraries, including C++, libc++, and TLSSL standard library like mbTLS, OpenSSL, that provide necessary functionalities for developers to write their own enclave programs. And to use those APIs from libraries, you will we try to provide the user experience just like as they are writing a normal program outside the enclave. For the attestation, OE has a plugin models that provide generalize and simplify the attestation process. So it provides a high-level API to just generate and verify an enclave code and the code for the attestation. And the plugin models means that each different TE can have their own implementation that to specify the low-level detail to how to handle and generate the enclave code. For example, currently we support the SGX plugin to handle the SGX specific attestations. So the OE architecture can corresponding to a normal TE model. There's a host running on trust world. Sometimes you may heard the term REE, rich execution environment. These are basically referred to the similar untrusted world. And the trusted world is basically where the enclave resides. The host program in general just responsible for bootstrapping an enclave program. That is done through the help of the host libraries provided by the Open Enclave. And the enclave program that developed by developer along with the entire Open Enclave runtime stack is all packaged together, loading to the enclave and sit inside the trusted bundle. So these basically provide general support to run any C and C++ programs. For functions that are not available inside enclave, for the example, the syscode we just mentioned, it will still call out to the host to get those functions back. And OE also tries to best ensure the security, those callouts are done in a secure manner. Okay, let's take a further look on what the interaction between a host and an enclave program. So the host take a ELF binary as an input. So that is the same for both Linux and Windows support. And once take the input, the host program uses the Open Enclave API to create enclave. And OE allows developer to define enclave and host functions that can be invoked by the other side. For example, an host program can invoke an enclave program through an echo. And enclave program can invoke a host function through an opcode. So we have toolset to generate those edge routines to handle all the parameter passing and like interacting with the low-level T components to handle those for the users. Let's take an example on how these edge functions are defined. So each enclave program are associated with the EDL file, as we shown here. And this provide a syntax that to define the edge functions, both eCode and OCode, that can be used by an enclave. And the EDL user can also import, for example, import some predefined EDLs that provided by OE itself, and also to define their own echo and OCO in the trusted and untrusted sections. After defining an EDL file, and the user can just go ahead and use the tool provided by OE to generate this boundary C code that for both host and enclave side program. Okay, once we have those generated code ready, right, and developer can now go ahead to implement those defined echo and OCO in host side and enclave side. So this is pretty much an easy, simplified example that a developer can write on top of OE. On the host program, it's just like a normal C program that implements a main function. In this example, the main function takes an argument that expect to be a path to the signed enclave binary. And in this example, the main function used to create the OE underscore create hello world enclave API, given the binary, the path to the binary, and create a binary and create an enclave. Once enclave is created, the main function here invoke the enclave underscore hello world. This is an echo that defined by the EDL file we just see in the previous slide. So as you see, the invocation of echo and OCO just like a normal function calls. So it's basically abstract all the low-level things for the user and make the developed experience of writing an enclave program just like a normal program. But actually, what behind the scene is far more complicated, and that is really handled by the OE, so that a user don't need to take care of those low-level details. And we OE are try our best to handle those mechanisms in a secure manner. Okay, we'll have a quick walkthrough to what happened actually when a host program invoke an echo. So when a host invoke an echo, it go into our generated edge routines by our tools. It will firstly do serialize the arguments into buffers, and then at this point transfer the execution to the enclave. And enclave side will. So keep in mind that only enclave can access host memory, but host cannot access any memory that protected by the enclave. So in this case, enclave will take care of all these data transfer between the host and the enclave. In this example of echo, once transfer action to the enclave will copy the buffers that put by the host inside the enclave and do the unserialize and do necessary check to make sure there's no bad inputs feeded by host. And then at this point, it's really invoke the actual implementation of the echo inside an enclave. And then you use similar manner to transfer back the return, if there are any return values, back to the host. And at last, return to the invocation of the echo. So with these underlying mechanisms, the invocation of an echo is just like a normal program, normal function calls. And similarly, for the OCO mechanism, it really does the similar things, just in the reverse order, right? The enclave invoking OCO, the edge routines in the enclave side will serialize the argument to the buffer. But still, remember that it's only enclave can access host memory, so it's still enclave take care of all the data transferring that copy the buffers back to the host. and then also copy back the return value returned from the host. So this is similar mechanism that how we handle the OCO. So with all this support, we also want to mention this previously mentioned remote attestation plugins. To simplify this process, OE provide really high-level API. So we are not mentioning the detailed arguments here, but it's really just a get evidence and verified evidence API that a developer can use to get a code. And also for attestation service, for example, the Microsoft attestation service, to use the verified API that generate by a remote, get from the remote enclave program. So there are definitely lots of features we are not covered in this presentation. For example, there are more APIs for logging, sealing, and functionalities. And also we have we've done a lot on the toolchain integration, provides smooth developer experience on both Linux and Windows. And we also have the IDE integration with Visual Studio and VS Code. We also have this simulation mode that allows developer to run app, to try out their app with the OE programming model that run without T hardware. And keep in mind that the projects keep growing, so there are more features to come in the near future. So back to one point that we want to mention is really what is the position of the OE SDK in the ecosystem. So it is really an abstract layer that abstract all low-level details that developers don't need to handle. But it's also close enough for a developer to write their T application or firmware. So the one direction is really allow a developer to write an enclave program in the ground-up manner. This will brings a really lowest TCP. For example, the cloud services may use this manner to only put the security critical code inside the enclave, while leave the other code on the host. Also, OE provide a great foundations to implement high-level framework to implement rich confidential computing apps. For example, there's a confidential consortium framework that allows to write a multi-compute or blockchain app. Also, the Edgeless RT, the Eagle we just see in the previous presentation. And there's a SGX LKL and Mysticals that take the LibOS based design that support modified applications. So this demonstrates that OE serves a really great foundation for those framework that enrich the confidential computing communities. So we want to bring out one use case that how the Mysticals is built on top of OE. So it's really a LibOS-like design that supports an T application with lift and shift approach for either native or containerized applications. And for the aims to support different TEEs, and for current implementation for SGX support is based on the Open Enclave. For more information, please refer to the link we put here. So we also want to show a demo that demonstrates an idea how we can enable more high-level language on top of OE. I'll just show a quick demo. Okay. So here is really a prototype of showing case of how we can run your binary Rust code enclave, inside enclave. So here we can see it's really a structure that I showed previously. And we have an EDL file that define here only one echo. And in the host side program is just run the same as similar to what I showed in this previous slide. It's a program that create an enclave and invoke the echo defined in the EDL file. So here we can see there's in the enclave side there is no C code, and it's really just if you're familiar with Rust, it's just a standard structure of a Rust cargo project, and it includes a Rust library that implement the echo. It will does the print hello from Rust string. Okay, then we'll just do a make to compile both host and enclave. So we'll not go into this detail, but we'll just run to see. So if you can see, this is what we showed previously. The host program take enclave binary as an input, and then basically does the load and invoke a function defined by enclave. Okay, so back to the slide. It's really demonstrate the example of how a community can build more high-level stuff on top of OE. We serve a good foundation that you don't need to worry about the low-level details. How it can evolve? Definitely go and check our our GitHub page and follow the docs to write your own enclave programs. And there are lots of ways to contribute through the GitHub. You can report bugs, ask any question, and provide any feedback. And if you want to get involved more, there's a good first issue label you can search on the issues. And we are more than welcome to receive any pull request. And we also have a weekly open meetings that is completely open, that people who are interested can feel free to join. So with that, I'll conclude. This will conclude my talk, and I would like to take any questions.
Thank you so much.
Thank you very much.
I see Moritz joining.
Yeah, I take the I'm the new Felix for this session.
Okay.
There were a couple of questions in the chat. Let me pick them up. The first one I saw was about AMD SEV attestation. Is there anything planned to support that as well?
I think that we don't have that. It's not part of the roadmap currently, and I don't have the answer for that. But maybe, and because it is kind of a VM-based approach, right? Kind of have a different design for what OE3 target. So yeah, we will consider that later, but I can't give any more detail on that right now.
All right. There was a second question about what application Mitikos is supporting as of now today.
So it's really go and check the page. So it's really support and allow for support and unmodified POSIX applications, and you can pretty much run your binary as it is. You have like multiple samples in the page, I believe, and also support containerized application. For more information, I believe if Ava on the chat, she can provide more detail on that.
Yes, Stefano already posted the link, so you can find it there. There were a couple of questions about the Rust. I think, yeah, you showed the Rust bindings. Somebody was asking if this is a Rust SDK. And then Thomas asked if the Rust bindings are for both host and enclave part of the app.
So that part is really just a POC, and we don't really have a investment on that, but it just used to demonstrate the capability on you can potential to building the Rust on top of the OE SDK. So yeah, we don't have really much things to talk about on that, but we're actually still in the brainstorming age, and more than welcome if anyone are interested. We can collaborate together.
Great. Another question from Thomas was about improving switchless OCall performance. Is there anything planned, having something tailored specific for socket I/O, improving performance there?
Yeah, I think as long as there's a demand, right? One can. So we are in the really open community, and we are really based on any demand raised by the feedbacks we get from community or any customer that use OE SDK. And if that is there any desired features, we are more than welcome to discuss that in our SIG meetings, and we will have basically evaluate and prioritize, and we'll just go implement if necessary, and that will help our community. So that is definitely something we can consider. Yeah,
sounds great. Yeah, because we are great fans of Open Enclave. All our tools depend on your SDK, so that's something we definitely will follow up on. Great. One more question I saw, I'm not entirely sure I understand, is having Microsoft as the attestation authority. Do we still need to get the signing keys from Intel, or do we get them from Microsoft? Maybe I missed something. I don't know exactly what this refers to. Maybe you know.
I think the association detail use case is really cloud specific, right? And for example, you are using different cloud environment. The environment will provide different kind of the certificates chain or the key for you. So that is really depend on use cases, and I don't think we as an SDK we just provide the interfaces for you can use, right? But how you use that is really depend on any attestation service. For example, Microsoft has their own implementation on using API to verify the code, but the others will have different one. But we just provide an implementation API for those to use. Right.
Maybe one more question from me that goes maybe into a similar direction. We had the understanding that for SGXD cap, you have this cache PCCS in the middle of your architecture, and we had the understanding that you need some kind of trusted time to make sure you're not fooled by some cache invalidation tricks or something. And I mean cache by the decap cache, not the processor cache. Yeah. Is there anything planned with trusted time inside Open Enclave?
Yeah, we're definitely that is one of the known implementation. We have document and point out in our documentation that is really something we really want to address. But given the limitation of current SGX hardware, we are unable to address that. But once it is solved by the hardware, then we'll definitely take our action to address that concern. But that is definitely one limitation inherent from the hardware.
Okay.
Right. Thank you.
I need to cut here.
Yeah.
In terms of time. Thank you so much, Ming-Wei. Thanks for your answers and thanks for your talk. It was great having you.